some of the common mistakes usually students do in chapter 7 at chemical energetics, and what are the tricks and how you can tackle these mistakes in your exam. Let's see one by one. Okay, first, which process involves a chemical change? Most of the students already know that what is a chemical change and what is a physical change, but the common mistake they usually do in this question when they are given with the option of adding sodium to water and dissolving sodium chloride in water. They forget that sodium is a metal and sodium chloride is an ionic compound, it is a salt. Okay, so they just think that okay, both options are actually not the chemical change, they are physical change. No, please read the question carefully. This is a sodium metal, and metals don't dissolve in water, they actually react with water, they form a new compound with water. So that's why adding sodium in water is a chemical change. Adding sodium chloride in water, it is a physical change, okay? But sodium in water is a chemical change. So that's why option A is the right option. Let's see question 41. Again, a gas is produced when calcium carbonate is heated. Which type of change is this one? So sometimes the student usually forget that, okay, which option should I choose? Should I choose exothermic or separation or whatever? These they are asking about a change. So there are only two types of changes, physical change and chemical change. They are not asking about the type of the reaction. So you can just look at this one. A gas is produced, it means something new has been made. Gas is produced means that now you get a new compound, so this change will be a chemical change. So that's why option A will be the right option. Okay, let's see another question. 10 gram of ammonium nitrate are added to water at 25 degrees Celsius and the mixture was stirred. The ammonium nitrate dissolved and for 1 minute the temperature of the solution 10 degrees Celsius. Okay, so now you already know the difference between chemical change and physical change. Now there is another important concept, that is endothermic and exothermic. Students usually get confused even if they know the answer. They know that exo means the exit of heat, right? Exit of heat means the surrounding temperature will be higher now, higher. And for endothermic, they think that surrounding temperature will be lower, right? But the biggest mistake they usually do, they don't consider solution as a surrounding. They think that solution is actually not a surrounding. So in exam, if they tell you that okay, the water is ammonium nitrate is was added to the water, the temperature was 25. Later, the temperature of the solution changed to 10. So they think, okay, the temperature of the solution is 10. So what does it mean? It means it's an exothermic reaction. Why? Because all the heat is given out. Now that's why the temperature of the solution is reduced. That is wrong. Solution is actually your surrounding. How you will know that this is surrounding? They are asking about surrounding. The simplest trick is read the question, and if the word is temperature, then it means they are talking about surrounding. Even they tell you that the temperature of water, you see, water is our reactant in this, but still you cannot choose it as exothermic. Temperature was 25, then it becomes 10, so the temperature is reduced. It means all the surrounding temperature has been reduced. So in endothermic, the surrounding temperature will be lower. So this reaction is endothermic. You just have to look at the word temperature. If the temperature word is used, it means they are talking about surrounding, not about the solution or the reaction mixture inside. Okay, these all things are actually your surrounding. Even your reaction mixture is a surrounding. So if you see the word temperature and it is reducing, it means it is endothermic because they are talking about the surrounding. So which option is right? Option A is the correct option. Let's see another example. When ammonium nitrate is added to water, the temperature of the water decreases. Again, the student will think, okay, the water temperature has decreased. What does it mean? It means all the heat is given out, right? So it is exothermic. No. If you see the word, again, I'm telling you, the temperature word, it means they are talking about the surrounding. So if the temperature of the surrounding, it means they are talking about surrounding, it decreased. So now the reaction is actually endothermic. Okay, so which explain these observation? First, the ammonium nitrate dissolve in the water, it reacts with the water. But first of all, let's see the temperature of the water decrease. So it means it's an endothermic reaction. So these two options are right. The process is endothermic. Now let's see another information. The ammonium nitrate can be recovered by evaporating the water added. So what does it mean? It means you can get back your ammonium nitrate, right? So this solution is actually not a chemical change. It is a physical change. Why? Because you just have to do the evaporation process. You don't have to do any other chemical reaction. It's just you have to evaporate the water, just do the process of evaporation. So what you are going to get, you are going to get ammonium nitrate, right? You can get back your ammonium nitrate solid. So this reaction is what? The ammonium nitrate is dissolved in water. It has not reacted with water, because if it has reacted with water, you cannot get back ammonium nitrate just by evaporation. Okay, so evaporation, if it is giving you back your own reactant, then it means it's a physical change, and physical change is actually like dissolving in the water. So option A is the right option. 44. The initial and final temperature of four different reactions are measured. Which reaction is the least exothermic? Okay, now the students already know that initial temperature and final temperature difference. They can just calculate. If you see here, the difference is 6, right? If you see here, the difference is 3 maybe. If you see the difference here, maybe 5. Okay, I'm just calculating. I'm not calculating. I'm just letting you know. Maybe, yeah, okay. And this is 4. And the student will choose what? Least exothermic. It means this is the right. Wrong. You don't have to choose like randomly by just finding the difference. First of all, you have to, because they are asking about exothermic, they are not asking about the difference. So first you have to see which one of them are exothermic, which reactions are exothermic. So remember that in exothermic reaction, the final temperature, surrounding temperature should be higher. Okay, initial should be lower and the final should be higher. So if you look over here, the initial was 19, final is 25. It means the high surrounding temperature has been increased. So this is exothermic. Now let's see any other option. 21, 18, it is reduced. This one is not exothermic. 22 was the starting and the final is 17, not exothermic. 22 was the starting one and the final is 26. It means it has been increased, right? The surrounding temperature has increased. So these two are actually exothermic. So now you have to decide which one is the least one. Now you have to calculate the difference. If the difference is less, the one which has a less difference, it means it is the least exothermic. So 25 minus 19, the answer is 6. Okay, so the 6 is the answer, whereas this, the answer is 4. So it means which one is the least exothermic? It is the option D, because the answer is 4. Okay, so option D is the right answer. So first you have to find which of these reactions are exothermic, and then you have to calculate the difference. Okay, so that's why option D is the right option. Question 45. Which statement about exothermic and endothermic reactions are correct? Already I told you, students already know that exothermic means that the heat is given out, but they get confused with some of the statements like C. During an exothermic reaction, heat is given out. Yes, that's right. The temperature of endothermic reaction goes up because heat is taken in. Student will think, yes, that's right. Why? Because endothermic reactions always take in the heat. But that's not the temperature. The temperature of endothermic reaction will not. Temperature is for the surrounding, okay? The heat of endothermic reaction actually goes up, right? So that's why you cannot use the word temperature for the reaction. The reaction heat is actually higher. Okay, not the temperature. The temperature is actually for the surrounding world. So surrounding temperature never goes up for endothermic reaction. So that's why this option is wrong. Okay, temperature is always lower because the heat is taken in. So now third option, burning methane. Methane, we already know it's a natural gas. It's a part of natural gas. So whenever you are burning a fuel, it's a fuel. So the reactions are always exothermic. They give a lot of heat. So option 1 and 3 are the right option. That is the option C. Okay, so option C is the only correct option. Let's see for 46. Which statement defines the activation energy? All the students know that it is the amount of energy that is needed to start a reaction. But the biggest mistake the student usually do, they forget that this energy is maximum or minimum. Sometimes the student choose the word maximum. That is wrong. It is not the maximum amount of energy. It is actually the minimum amount of energy that the particles must have to react. Okay, so that's why option A is the right option. So it is the minimum amount of energy that the reacting particles must have to react. So option A is the right option. Okay, so many students get confused with reaction pathway diagram, and at least you will get one question related to reaction pathway diagram. So for this one, there are some tricks that you have to remember. Okay, you can practice for that, and how you can Which diagrams is correctly labeled? First of all, you have to see the labeling. Always I will show you that what does labeling means and how it is. It is same for endo and exo. Delta H is one of the important component of this diagram. Okay, how you know what is delta H? It is always between reactant and product. Wherever the reactant and product word is written, it will be delta H. The space between reactant and product is actually your delta H. Okay, so can you see here, this is your reactant, this is your product, so the space between it is actually delta H. So this option is right. Let's see here, reactant and products. No, this is wrong because it is coming from the top. So this means it's wrong. Reactant and product, it should be delta H. So now this is also wrong. Reactant and product, it's always between the space. So this one is right. So these two options are right. Okay, another important thing you have to remember about the arrow sign. Okay, the arrow sign for exothermic is always like this, downward. For endo, it is always upward. Why upward? Because upward is showing that it is taken in. Downward is showing that it is released. Okay, in exothermic, the heat is actually released. So that's why delta H is always negative for exothermic, and the arrow sign is always toward the downside. Can you see it is down? It is down. So it means also right. Now let's see about activation energy. And another important component or another important part of this diagram is EA. Remember that EA, even if the reaction is endothermic or exothermic, EA is always between the reactant and the top of this diagram. Okay, the top of this arrow. So for example, this is, so from here, this is your picture, okay, or this is reaction. So this is your EA. So EA is always from reactant to the top of the diagram. So can you see here, reactant to the top is always EA. So this is right. Reactant to the top is EA. Yes, that is also right. Reactant to the top is EA. That is wrong now. Okay, this is delta H, so it's wrong. Reactant to the top is always EA. So that's also right. But we can see here now, these two options are still right. So now what is the difference? Which is wrong? Here you can see for EA, it is always upward because EA is actually endothermic. EA, you need the energy. So for endothermic, you see the arrows are always upward. Even if a reaction is exothermic or endothermic, EA is always positive and the arrow should always be upward because it is moving from reactant to the top, right? So the arrow should be like this, towards the top. Arrow should be towards the top, but it is wrong. Can you see the arrow is downward? So that's why option A is the only right option in this picture. Okay, so I hope this is clear to you. What is delta H? Delta H is always between reactant and product, both in exo and endo. Okay, and EA is always from reactant to the top, both in exo and endo. And the arrow should always be upward for EA, activation energy. For delta H, the arrow should always be upward for endothermic, but for exothermic, it should always be downwards. Okay, so that's why option A is the right option over here. Let's see another example of the reaction pathway diagram and how you can differentiate now between exothermic and endothermic diagrams. Okay, if you see here, two reaction pathway diagrams are shown. Which arrow represent the activation energy? Here you have to find. And for a reaction which release the thermal energy, I already told you activation energy is the energy that is required to break the bonds, right? So it will start from reactants to the top. So reactants to the top, this is your reactant and this is the top. So A is your activation energy. Reactant to the top, C is your activation energy, right? Now which option is right, A or C? This one you have to decide on the base of the endo or exothermic reaction, right? And they say a reaction which release the thermal energy. So which reaction release the thermal energy? Of course, these are exothermic reaction. Exo means exit, out of the heat. The heat is given out. So this means they are talking about exothermic reaction. So for this purpose, you must need to know the difference between exothermic pictures and endothermic pictures. Exothermic pictures, you will always find that the reactants are on the top and the products are at the bottom. Why? Because all the heat is given out. So that's why your products have lower energy level in exothermic reaction. Can you find here now which one has lower energy level, reactant or the product? So from the 0 point whenever a thing is starting, this is now your reactant, right? It is starting at the zero level. So this is your reactant, this is your product. Now this is your reactant and this is your product. Which product is at lower energy level? If you see, the product here is lower energy level. Reactants are at the top energy level. So it means this picture is actually for exothermic reaction. So option A is the right option for this question. I hope this is clear to you that what is the difference between exothermic picture and the endothermic picture. Again, let's see this question. The energy level diagram for a reaction is shown. Which row is correct? First of all, let's define this diagram. Is it endothermic diagram or exothermic? If you see, the reactants are below and products are at the top. It means, what does it mean? And if you see, the delta H also direction is upward. So it means this is endothermic picture. Why? Because the products are at higher energy level. Reactants are at lower energy level. They gain a lot of energy, and then now the products have not released much energy, so that's why the products have more energy, and this diagram is of endothermic. Now it's already decided endothermic, so option B or C can be right. Let's see now for the sign of delta H. The sign for delta H, if you see, the arrows are upward. So sign for delta H for endothermic reaction is always positive. Okay. So positive sign for the delta H is positive. Both options are right. Now let's see for activation energy. Activation energy, the arrows are always upward, so it will be also positive. Activation energy sign is always positive both for endothermic and exothermic reaction. So that's why option B is the right option. Let's see another example of the question and see which diagram is this. The energy level diagram for a reaction is shown. Which row is correct? Now if you see, your reactants are at the top and the product is at the bottom. So this reaction is actually for exothermic now, because all the heat is given out. So now your products are at lower energy level. So first of all, we have to find where the exothermic is written. Yes, this one is exothermic. A or D option can be right. Now let's see for delta H. If you see, the delta H row is downward, it means it is negative. Delta H is always negative for the exothermic reaction. Why negative? Because all the heat is given out. Now the system has less heat. So that's why delta H will be negative. So can you see, delta H is negative? What about activation energy? I already have told you that activation energy for endothermic and exothermic reaction will always be positive, because the arrow is upward, right? In endothermic, it's also upward. In exothermic, it is also upward. So the delta H will be still positive for exothermic reaction. So the option D is the right option. Let's see another question. This is a must question in exam, in which you have to calculate the bond energy. And when you have to calculate the bond energy, it has nothing to do with the diagram picture. Okay, the bond energy formula is different. Your answer for exothermic reaction should always be negative, and for your endothermic reaction, it should always be positive. How you can calculate delta H? The formula for calculating the bond energy is, you have to remember that the bond energy of the reactant, okay, minus the bond energy of the product. This is the formula you have, and you have to calculate the bond energy. The biggest mistake, the students usually know that they know the formula, but when they are calculating, they use the wrong values. How they use the wrong values? Because they misinterpret that how many bonds are present here. So to find the right number of bonds, you have to draw the structure formula. Only structure formula can help you to decide the number of bonds and the type of bond. For example, if you have CH4, then you have to draw the structure. C is 1 and we have 4H. So how many CH bonds we have? 1, 2, 3, 4. Okay. So now you have 4 CH bonds. This is CH. 4, 1, 2 into 4. Oxygen. Now let's see for oxygen. The students usually don't know how to make the oxygen structure O2. I already told you, whenever you are drawing the structure formula, you have to remember the oxidation state. So oxygen needs 2 electrons to complete its outermost shell. It has oxidation state 2, so it means it will make double bond. So that's why oxygen and oxygen will have a double bond. And how many oxygen you have now here? 2. So it means you have 1 bond and this is 2. So total 2 oxygen bonds you have. That is 498. Sometimes the student miss this coefficient and they do a lot of mistake. Don't forget these coefficients. 498 into 2 will be the right answer. So when you calculate, this is the bond energy of the reactant. Okay. What about the product? Again, if you look at the carbon dioxide, you have to draw the structure and you have to complete the electronic configuration. Carbon always make 4 bonds. Oxygen always make 2 bonds. So this is the right structure. So carbon double bond, how many you have? 2. Okay. So you have 2 carbon double bond, that is 743 into 2. And then how many OH bond you have? In H2O, if you see the structure is like HOH. Oxygen is making 2 bonds, right? 1, 2. Hydrogen is just making 1 bond. This hydrogen is also making 1 bond. So this is the right structure formula for water. But if you see, we have 2 water molecules. So how many OH bonds we have? 1, 2, and this is 2. 2 twos are 4. So total we have 4 OH bonds. So your answer should be 4 into 463 and then plus 743 into 2. So this value will come here and this one will come here. Okay, this one will come here and this one will come here. So then you can calculate the difference and you will know the right answer. So please always draw the structure formulas for calculating the right answers. Otherwise, you can do any mistake in the calculation and your answer will be totally different. So the right option is here, B. Okay, let's see question 52. Hydrogen burns exothermically in oxygen. The equation for the reaction is this. Okay, we can see over here. Again, they have given you bond energies and you have to just calculate the delta H value. What is the energy given out? It means the delta H you have to find. So it is simple. The students already know the formula that delta H is equal to the bond energies of the reactant minus, okay, the product, right? But the common mistake the students will do, they don't know how to draw the structure formula and how to find the bonds, that which bond is present. So first of all, whenever you are writing the bonds, you have to first make the structure formula. If you have H2 here, so it means the bond is HH. That is the structure formula for hydrogen. So how many hydrogens you have now here? Only one hydrogen bond. But if you see here in the coefficient, it is written 2. So it means now you have 2 hydrogen bonds. Usually the student forget to add the coefficient. So this coefficient must be here. So it means you have 2 into 4 into 3, 6 is HH. And then how many oxygen bonds you have? You have to draw the structure. So only 1 bond of oxygen. Don't get confused that you have 2 oxygen, so now you have 2 bond. No, you have just 1 double bond of oxygen, that is 498. So this is the bond energy of the reaction. You have to calculate this one. And how you can calculate for the product is simple. You have to look for the structure formula of the water, that is HOH. So it means how many bonds you have? 1, 2. 2 OH bonds you have in one molecule. But what is here? It is written 2 molecules of water. So 2 into 2 means you have 4 OH bonds. So that's why your product is 464 into 4. So please don't forget about the coefficients. The biggest mistake the student usually do is in the coefficients. They forget to write the coefficient and then they don't multiply it with their answer. Second mistake they usually do is that they don't know how to write the structure formula. So be very careful when you are drawing the structure formula. Then you can decide that which bond is present and how many number of the bonds are present. Okay, then you can exactly calculate the right answer. So the answer for this question is C. You can calculate using these values and you will see your answer will be C. Okay, so remember what you have to remember. Don't forget the coefficients, and the second, always draw the structure formula to know the type and the number of the bond. Let's see another question. Question 53. Which equation represent an endothermic reaction? So now if the student will look at this question, they will be usually confused that how they will know that which one is endothermic reaction. The biggest trick I will give you for these type of reaction is that endothermic reaction is always about bond break. Another thing that you have to remember that all the oxygen reactions are exothermic. So if you see any reaction that is with oxygen molecule, it means it's the burning. And burning reactions are always exothermic. So can you see here, oxygen is reacting over here right? So this is exothermic. This option is included. Let's see for this one, the bond making. You are making two bonds between hydrogen and hydrogen. Bond making is always exothermic reaction because a lot of energy is released when the bonds are made. So this option is also now excluded. Another example is the water reaction with the metals. All reactions of water with metals are exothermic. So now you are only left with this one in which the bond is breaking. Bond breaking is always endothermic. If you see, before we have a chlorine-chlorine bond, and now this chlorine becomes an atom. Before it was a molecule, the bond has broken. So whenever the bond breaking take place, it's endothermic reaction. So that's why option A is the right option. So which tricks I have already given you? First, all the oxygen reactions, if you have oxygen molecules, they will be exothermic. All the metal reactions with water, they are also exothermic reactions, okay? And bond making is also exothermic. And what is endothermic? Bond breaking. Bond breaking is endothermic. Photosynthesis reaction is also endothermic. Cooking process is also endothermic reaction. You have to remember some of these reactions. Decomposition reaction, if you see anything is breaking into two, you have one reactant and it give you two products, then that is also endothermic reaction, okay? Remember that decomposition, photosynthesis, cooking, these all are endothermic reaction. Bond breaking, also endothermic reaction. So option A is right for this question. Let's see another question. Which statement about endothermic reactions are correct? So this is related to bond energies. If you see here, the energy of the product is higher or lower, you have to look at that one. And it is related to the energy level diagram. If in exam you don't get energy level diagram, then you will get at least this question that is related to energy level diagram. So before answering this question, and you have to see that they are already giving you the energy of the products, right? So let's see one by one. The energy of the product is greater than the energy of the reactants. Endothermic reaction. If you see the energy level diagram, reactants are always at the bottom and products are always at the top in endothermic reactions, right? So it means energy of the product is greater. Yes, it's right. Energy of the product is greater than the energy of the reactant. This option is right. The energy of the reactant is greater than the energy of product. Of course, it is opposite, so it's wrong. The temperature of the surrounding increases during the reaction. That is another thing you have to remember, that in endothermic reaction, the surrounding temperature always decrease. So that's why this option is wrong. The temperature of the surrounding decrease during the reaction. So option 1 and 4 are the right option. That is option B. Okay, so option B is correct. Question 55, which statement describe an exothermic reaction? Now, if you see, the energy absorbed for bond breaking is greater. So now this question is related to breaking the bonds or making the bonds. Bond breaking is always endothermic. Bond breaking is endothermic reaction. So it means for exothermic, the bond breaking should be less, right? Because if bond breaking is more, it means it's an endothermic reaction. So we have to see the energy absorbed for bond breaking is greater. Wrong. For exothermic, it should be less. The energy absorbed for bond breaking is less. Yes, this option is right. The energy released by bond break. Again, the statement is wrong because energy is never released when the bonds are broken. The bonds are broken with the help of activation energy. That energy is actually the energy absorbed, energy taken in to break the bonds, okay? Energy is never released when bonds are breaking. It is only released when bonds are made. So bond making is exothermic and energy is released, okay? And bond breaking is endothermic. So this option is also wrong. Now let's see the energy released by bond breaking. Again, this statement is wrong. Energy is never released when the bonds are broken. It is always absorbed. So which option we are left with? Option B. The energy absorbed for the bond breaking is less than the energy released by the bond formation. Yes, when the bonds are formed, the energy releases more in exothermic reaction and bond breaking is less. Okay, so that's why option B is the right option for this question. Let's see another question. Which statement about endothermic and exothermic reaction is correct? Again, the same statement about the bond breaking and bond making. For this one, you have to remember that bond breaking is always endothermic, okay? Endothermic. And bond making is exothermic. And how you can remember from this trick, when you are making new friends, then in the start you guys are so excited, you share everything with each other. What does that mean? It means you are so excited, you have more energy, right? So bond making is exothermic. How? Because a lot of heat is given out. So that's why you can just remember from this trick that bond making is always exothermic, because a lot of energy is given out, right? And bond breaking is endothermic, because usually whenever you end your friendship with your friends or someone, what you will do, usually these are like a cold type relations, and then you will end up those relations, right? So the end product is cold. What does it mean? It's endothermic. So you can remember from this that bond breaking is always endothermic and bond making is exothermic. So now we can see the options which are right. In endothermic reaction, less energy is absorbed in bond breaking. Endothermic means bond breaking should be more, right? Bond breaking, so less energy, no. More energy should be absorbed. So that's why this option is wrong. In an endothermic reaction, the activation energy is always higher than in an exothermic reaction. That is wrong. Why? Because the activation energy always depend on different type of reaction. It does not depend on endothermic or exothermic, because activation energy is the minimum energy to start a chemical reaction. So it differs based on the type of the reaction, not on the like endothermic or exothermic. For some reaction of exothermic, it can be very high. For some endothermic reaction, it can be very low. So it depends only on the type of the reaction, not on the base of endothermic or exothermic. Okay, so this option is also wrong. In an exothermic reaction, okay, the more energy is absorbed. Again, wrong. Exothermic reaction always release more energy. They don't absorb more energy. So you don't have to read the complete statement. It's only you just know that okay, more energy is absorbed. It's wrong. In exothermic, more energy is never absorbed. In an exothermic reaction, the reactants are higher on an energy level diagram than the product. Yes, this option is right. If you remember the energy level diagram, the products are always at lower energy level in exothermic reaction, because all the heat is given out, and the reactants have more energy. That's why they are giving the heat, right? So the reactants are higher on the energy level diagram than the products. So option D is the right option.